Good morning, pilot teachers and students. Good morning, class.
Good morning, sir.
All right, thank you. You may sit down. Basically, in this lesson, we'll be going through and looking at the current, especially electric current in circuits. Now, you will find that there are two different circuits, the series circuit and also the parallel circuit. So, I will give you some of the diagrams which shows you how you can connect the ammeters to measure the electrical current, especially in these two circuits. So for those pilot students and teachers, I will give you the diagram. There are 5 diagrams that will be given to you. So what you will be doing is to go through quickly, copy each one of those, and then I will provide ammeters for you to connect and then measure the current, especially in series and also the parallel circuit. So here are the diagrams. That is diagram number 1. For the diagram, you will find that there is only one ammeter that is connected in series with a resistor, and then you have 2 cells which are also in series. So for the diagram, you go through quickly and then just sketch it down, and there will be 4 more which will come later. Two for this. Okay, 1 4. Just have this. First one will go to that side. Pass it down. All right, this will be diagram B. All right, for that you find that there are also 2 resistors in series, and then you find 1 ammeter that is to measure the current. Here is the next diagram, that is diagram C. Okay, what do you think will be the resistors in? Okay, good. They're in parallel. Okay, here will be information based on the first three diagrams. You'll find that especially in a series circuit, the diagrams as the ones shown, or those ones shown in A, B, C, and A, B, and C. Okay, the ammeters connected in the circuits will have different readings. Okay. Here is diagram D. Right in here you'll find that there are different ammeters, ammeter 1, 2, and 3, which are all in series and then trying to measure current at different points in the circuit. Right, that is point 1, where you have ammeter 1, and then you have point 2, which is ammeter 2, which comes between two resistors. Okay, that is probably resistor 1 and resistor 2. Right in here you also have ammeter 3, which is also trying to measure current at that point. Right, so what do you think would be the size of the current at this point, that point, and that point? Okay, point 3. If you're connecting these ammeters as A1 for ammeter 1, A2 for ammeter 2, and A3 for ammeter 3. So what would be the reading of each one of these? Right, so you can consider that one also. Right, so this is diagram D. Right, quickly copy that, and then I'll give you the last diagram, and after that I will give you the activity questions. And from that you can use those instruments to or connect the ammeters and then start measuring. All right, to our final diagram. All right, with this just a few information on the last diagram, that is diagram D. You'll find that the ammeter readings of all the current are the same all the way around the circuit. So at one of those, if you have 0.1 for ammeter 1, the current will be the same. If you decide to connect the ammeter at 0.2, the current will be also the same as ammeter 1. And also ammeter 3 will be the same to ammeter 1 and ammeter 2. Right, that is just information to emphasize on diagram D. Okay. Okay, that is the final diagram, and that shows you the current, especially in parallel circuit. Okay, looking at the current that is passing through ammeter 1, 2, and 3, and 2 and 3 are connected in parallel, while the ammeter 1 is connected in series. especially for this when you have that, right, because it is from negative to the negative terminal of the ammeter. That is why it must be connected in that manner. If it is positive, it must be from positive to the negative, okay, from where it comes, and then in here from positive to the positive. All right, here are your activity questions that you should do following those diagrams. Okay, activity 1 is to connect the ammeters as shown in D and E and give you readings. All right, for question number 2 is to explain why you obtain the type of reading. Okay, quickly copy those 2 questions and I'll give you the last questions and you can start after that. One more. Okay. Right, maybe you can try with 3 of the ammeters. Otherwise, you can only use 2 ammeters for diagram D. Right, for that diagram, you have to connect the ammeters at different points. Right, it does not necessarily require you to connect 3 of them. Okay, you can have 2 or as 4. Right, the connecting wires are here. One member of the group can come up and then collect the connectors as well as the You don't need to connect the resistors. You don't have to. Okay, we don't want resistors. You can use the um, lamps if you want to. Yeah. All right, for the final question in a series circuit, there's the one shown in A, B, and C, including, okay, those ones, especially those A, B, and C. The diagrams or the ammeters are connected in circuits, but they have different readings. Why is that? Right. In place of a resistor, you can use the lamps. Each one of these lamps are all the same voltage, and that means they will have the same usage of current. Okay, about 3.8. Okay, how many lamps have you got? 2. How many lamps have you got? 2 lamps. Okay. What will be? Okay. Each one of this group has 2. Anyway, you can only connect the ammeters and then measure the current. But this time you have to connect something like a resistor. Maybe you can use this variable resistor, but it should be down here. You know how to connect this one? Yes. Yeah. If you don't have this, connect this.
And this one?
Maybe we can connect one over here and then another one there, or one over there. Yeah. Which is a positive? This one is positive. Maybe we can break this one up. Just a one resistant and you measure it.
Yeah, we should the same scale. Ah, wait, what scale is this? This is 1 to 5. No, take it out. Put it on 5.
This is 5.
No, this is 5. This is 5. Let me show you. Ayan.
Easy. The one at the release.
No, it's not a switch. The switch must be on.
The light bulbs are not working. So, what is wrong? Eh?
Somewhere on.
Leave it. Let go of it. Let go of it.
Okay, so let's
What happened?
a battery and look at something. Put it down. There. There. And you
The current going through right now is 0.1.
Okay, point one, you can start connecting one over here and then measuring it. You have only one connector here. Let me see. Check to see whether it is really point one. Okay, place that one over there. Positive. Well,
can you anymore?
I don't think there is any more wires to. Okay, connect one over there. The short piece of wire. If you can maybe use only wires. Connecting wires. Maybe use only. Huh? Only this one. Are you still using it? No. One millimeter. Okay, you can measure that too. But then you can change and then measure at this point over here. Try to check the resistance. Okay, otherwise remove that resistor. Yeah.
Try measuring.
Yeah. Measure it. That's it. All right. Just wait until they have to finish connecting, and then probably they might send over. And Okay, what will be the reading? 0.2, you see it?
Yeah. 0 point.
Try that again. 0.2, okay. Kevin, try it.
Yeah.
Maybe the battery is
Okay, try it.
Okay, maybe you can try connecting that later on. We'll just go through and then what do you think would be happening to the amethys in D and E? Right, D and E, what will be the reading on each one of those?
Yeah.
Let me see how you connect this one. From there.
Next to this one, negative.
Okay, connect this. Just, yeah. Okay, put it this way. Check the lamps, otherwise if one is blown, you may have only one lamp, but yeah. Right, have you,
We are doing trying to do it now. It's on, it's already.
this one's,
It's okay. It's on the map.
Let's go.
this one's in series,
Okay,
are they?
okay.
They're all two.
Point two.
Okay, we'll just have your answers. You go through, disconnect this one and then have the E, connect E and then we can.
Let's go. Fast.
What is your reading?
2.8.
2.8. Okay, you disconnect that and then you connect that over there. Get the reading from. Yeah. Yeah. Or if you don't want to have that, probably you can connect another ammeter here. Okay. Disconnect that one quickly. Yeah. Okay, come. That is from -2. Sorry. This one should come over here. Okay, remove this. That's it. Okay. From -2, positive, and this one should come over there. Okay.
Okay.
connect this one.
Yep.
Yeah.
Wait. Okay. Don't touch it.
Guys, wait.
2 point.
Just drop in. It's 1 point. You see me?
Okay, that's enough. As long as you have how much is it?
About 2.
About 2.
I'm switching 2. Wait.
Okay.
Yeah. Yep. Just about 2. Yeah.
About 2.
Where did you touch it? Okay. This should be 2.
About 2. Okay.
2.
All right. You don't need to mess with it. Now you connect these ones in parallel and then have a look at it quickly. Okay, in parallel meaning that you can have this one there. Yeah. Yeah. Okay, just as it is, and then you connect another one over here. Quick.
But you're not following.
It's okay. You just connect that one, then have the get the reading.
What is the first one? 2.8. 2.8.
All right, I'll just give you 5 more minutes and then we'll go through. Maybe we'll take one group to come up and then explain on what the experiment was. Okay, what have you got? What is your... You, what happened? Have you checked the lamps? Okay, lamps are... Okay, this one is... Okay, all of them are okay.
0.5.
0.5.
0.5. 0.5. It's because of
Okay,
the
look at the brightness of the lamps. What happened?
it's
Okay, it's...
one is bright.
One is brighter than
One is not. It's 0.5.
0.5. So that's not that one.
Okay.
So the way it was the other chair.
All right, you can go through and then do your explanation if you want to.
Join the amps. Join. Positive. Wait.
Coming this way.
Split up this
One
one.
here. Yeah, put it here.
One on this side and one
Oh,
on this
wait,
side.
okay.
Yeah, for this one it will be here. It goes the other way. There's a positive here and a negative here.
Okay.
Wires. One will go there.
Okay, you can do that later on. What will be your explanation on this? That's it. Fourth diagram. What do you think will be happening, or what do you assume?
Yeah, that's A, B, C, D.
E.
E.
What will happen to the ammeter 1? Ammeter 1.
Ammeter 1 will have a reading which is
Half volt, or
more
is it
than
more than?
double. Adding both of these will get the reading for ammeter 1.
Okay. All right, good. So, okay. So for A, what did you find out for D? Ammeter D.
All of them, their readings were the same.
Same. Okay. You can now stand up and then explain so that later on the other groups can go through and then find out whether these are what you said were quite correct. Okay. Listen, you can go through and then connect those ammeters again later and then have a look at the readings. Okay, whether this will be according to what this group is going to say. So I will ask Sulaiman to stand up and then explain the first connection, that is diagram D, and also E. So you can now stand up, then explain D and E. Okay, one of you can explain D while the other one explain E.
For first diagram D, when we connected all the amps up as shown on the board, we came up with a reading of 0.2 for all the emitters. And when we did it for E, the reading on emitter 1 is the to get the reading on emitter 1, you add the readings on emitter 2 and emitter 3.
Okay, very good. For D, you'll find that especially when you're connecting ammeter in series circuit, it's just like a flow of water in a pipe. Okay, when you have only one, it'll be the same. Right, in here, ammeter 1 will have the same reading as ammeter 2. And these three will also have the same reading as ammeter 1 or either 2. Okay, so they will have the same or equal readings. Now in D, E, you'll find that let's say if this was 2 amps, Right, when it comes over here, it will have to divide. Right, that means 1 amp will be flowing in that circuit while another one will be flowing in that loop. So it divides up, meaning that half of this will be flowing in that ammeters, okay, whether that is ammeter 2 or 3. So in a parallel circuit, the current will have to divide, while in a series circuit, it is the same in any parts of the circuit. All right, for the last question, in a series circuit, that is diagram A, B, C, and, or rather A, B, and C, the ammeters connected in the circuits will have different reading. Why? Michael, can you tell us why would you don't do that question? Okay, those diagrams that you see, just look at the diagrams and then tell me why would they have different readings. All right. Samuel, you tell us why there will be different readings in A, B, and C. Okay. Right, Samuel.
Circuit A has one resistor, circuit B has two resistors, different reading, and circuit C has resistors in parallel.
All right, any more answers apart from, okay, Mary, you help him. All right, John, you tell us why would be the different reading in each one of these. Okay, you are.
The readings were different because of the resistors. Resistors were in parallel and in series. For A, there was only one resistor, so the reading was different. And for B, there were two resistors giving a different reading from the other two. And in C, the resistors were in parallel, so the reading will be different from the other two.
Okay, both of your answers are quite correct. Looking at the first one, because of the resistors, you will have different readings. Right, the first one has a resistor, only one resistor in series. That means reading will be different. The second diagram, or B, has two resistors in series. That means the reading will be also different. All right, the third diagram, which is diagram C, has two resistors in parallel. That is the reason why the reading of ammeters in each one of those diagrams, A, B, and C, will be different. Okay, very good. So that brings us to the end of the lesson. Now what you should know is that in a series circuit, the diagram, rather the current, when it is flowing through the circuit, it will be same in all parts of the circuit. Especially in a parallel circuit, the current will be dividing. That means if you decide to measure, let's say the current in series at one point, it will have to divide, especially when it comes to branches of that circuit. So it will give you equal amount for the ammeter readings. So that you can go through and then connect that later on and then find out more on these ammeters. So our keyword for our key phrase will be current in circuits. Right, you can all stand up now. Right, good afternoon. Violet teachers and students, good afternoon class. Good afternoon, sir. All right, thank you very much. You may sit down.